Hello everyone, welcome to my YouTube channel. Okay, so we'll look at this problem solving section, and we're going to consider some problems under the application of differentiation of functions. Right, so now this says that we should find the stationary point on the curve this, so and then find the nature of those points. Right, so we begin by finding the derivative of the function. So the derivative of f of x is equal to, if you take the derivative of this, you have 5x raised to power 2. The derivative of this is minus 30x, and then we have the derivative of 45x as 45. All right, and so the next thing is to equate this to 0 and then solve it quadratically. Okay, so there is a common factor for all the terms here, and that's equal to 0. And so if you solve this quadratically, you are going to have that this is equal to 5, so and that's equal to 0. So now here, to find the stationary points here, you will see that all you need to do is to equate this to 0, and if you do that, you are going to have that your x is actually equal to 3, and is going to be twice. That means you have the same root twice. This is your stationary point. However, once you have a stationary point that repeats itself, then that stationary point automatically tells you the nature, and that is called what? An inflection point. You may not really need to check, but if there is need, let's really check to confirm the nature. And remember how to confirm it. You take the derivative of the function 2 times. So let's differentiate this again. If we do that, we are going to have 10x minus 30. And so now recall that what we said, that for you to have a maximum point, if you substitute the value of the x you have, which is 3, that you should get a value that is less than 0. But if it's greater than 0, then it is minimum. But if it's exactly equal to 0, then what you have is an inflection point. And when you put x as 3 here, you will have 10 times 3 minus 30, which is exactly 0. And so that means you have an inflection point. Okay, so the last example we have in this section here says we should show that this point here is a stationary point of this curve, and then we should determine whether the point is a turning point. So amongst the 3 types of stationary points we have, the maximum, discover that only these 2 are turning points. So because I told you in the first video, which you need to watch if you have not seen it, that the maximum point is the point when the curve gets to, and it begins going down, and then the minimum point, it gets to it and it starts going up. So both of them are turning points, but that for the inflation point, there is no turning for the inflation point. Okay, so what they are asking us to actually do here is to check whether the point we will get here is a maximum or minimum. If it is not either of these two, then it is what? Not a turning point. All right, so let's go. So we find the derivative of this. Let us call it f of x. So if we differentiate it, we are going to have derivative of this is 1. Derivative of cos x is minus sine x. Okay, so to check whether this point is a stationary point, is that, remember, this is the x part of this point, and so if we make a substitution here, if it is a stationary point, then it should give us 0. Okay, so let's try to do that. So we want to substitute x as pi all over 2, and if we do that, we have 1 minus sine pi over 2, and of course we know pi over 2 in radian is 90, and sine 90 is 1. 1 minus 1 is 0. And so since we have the substitution of x as this and is giving us 0, therefore this point is a stationary point. Now we want to check whether the point is a turning point. To do that, we differentiate this again, and that's going to give us f prime prime of x as equal to, the derivative of this is 0. If you differentiate this, you will have minus cos x. And so when you substitute your x as pi over 2, you are going to have that this is minus cos pi over 2, and pi over cos of this is actually 0, and so that's going to give you what? 0. And so what you have here, when you substitute your x, is 0, and like in the previous example we did, whenever you substitute your x, the stationary point, and you have 0, then it is an inflation point. And so this is what? An inflation point. So it is not a turning point. All right. Okay, so please kindly subscribe to our YouTube channel. That's where we'll end for this video. And please comment, like, and share our YouTube videos. We'll see you in our next video. Bye.